So we're on A6, creating exponential equations. Hopefully you've printed out the worksheet. If not, you can get a piece of lined paper and follow again. So we've got our joke of the day, and I know winter is just about over, and probably all the snow is melted all around you, but here's an easy way to lose weight. Look at this. Look what this female snow person does. All I do is set the hairdryer at a high heat, and the pound just melt away. Wouldn't that be fun just to lose weight? Okay, this particular one or this particular video, you don't need graph paper this time, okay? But you do need a calculator, so you do need a calculator for it. Okay, exponential equations have a variable in the exponent, or functions. Sometimes they're called functions, sometimes, but they have a letter in the exponent. So look, here there's a letter in the exponent. There's a letter in the exponent, and there's a letter in the exponent. Okay, so exponential equations have a letter or variable in the exponent. Okay, the general equation for all of them is like this. Okay, y equals ac x. Growth increasing bigger, it's 1 plus. That c value is going to be bigger than 1. It's going to be 1 plus something. And decay, decreasing lower, shortens. So 1, this is decay, 1 minus. So that c will be 1 subtract something. Okay, C, no add and subtract when question says, is this doubles or halves? You're not going to use this formula. Just use the value. Okay, and then you're going to remember to turn a percent to a decimal dividing by 100. So we're going to create some equations. When there's an add or subtract, it'll tell you in the question, increases by this or decreases by that. Make sure to turn it into a decimal by dividing by 100. We'll do some examples, and then if it doesn't say add, subtract, when it says something, you just convert it, okay? You don't do a 1 plus or a 1 minus. Let's do some examples. So first thing, we're going to circle the exponential function. So we'll go over each one. So let's go over each one. So y equals 3x. Is there an exponent? No. This is definitely not one. There's not an exponent. That's a letter. Y equals 201.2 to the x. So there's an exponent right here. It's to the power of x. So we know this one here is definitely an exponential function. Okay, y equals 200 to the x. No exponent, so that's not. Y equals 4x squared. Oh, there's an exponent, but it's not a letter. The exponent has to be a letter, so it's not that one. Now you got a equals 3200.2 to the t. Yes, because look, this exponent here is a letter, so this is an exponential function, or in the exponential equation. And finally, a equals 5z. Well, the z's an exponent, so yes, this one's also an exponential equation. Okay, so all these ones here are exponential equations because they have an x or a letter at the exponent. We have to figure out if it's growth or if it's decay. So if it's growth, whatever's in the bracket's bigger than 1. So here, this is less than 1. The 0.5 here is less than 1. So this one's called a decay. Okay, so this is, let's see if I can do decay here. Decay. Maybe I just use the letter D. Okay, and G for growth. Okay, this next one, this is growth. So I'll just use a G because the 2 is bigger than 1. Okay, the 1.5 is bigger than 1. So that's another growth. See that 0.85 in the bracket, that's less than 1, so it's a decay. D. So the 2 decays are, this is the decay, and this is the decay, and the other 2 are growths. Because the value in the bracket's bigger than 1, it's a growth. It's less than 1, it's a decay. Now we're going to set up some equations. So write an equation for each one, okay? So let's take a look. A city started with a population of 220,000. Okay, each year its population increased by 23%. So first, 23% divided by 100 gives you 0.23. Okay, now it increased by 0.23. So we're gonna do this. Here's how we do the equation. We're gonna go population, we're going to go P for population equals, we're going to put our starting value 220,000. Then we're going to put a bracket and each year T for time. Okay, in the bracket, we're going to use it increased by 0.2. We're going to put increase. 1 plus 0.23. So 1 plus 0.23. So our population equals 220,001.23 to the power of t. Okay, we're just going to clone this page because I need more room. So I'm going to click on it and produce a clone of it. Okay, and now I got 2 of them. I'm going to delete this bottom. Now, P stands for population. Okay, and T is for time, and the time is in years. So first we take our percent, turn it to a decimal. Then we have to decide whether we add or subtract. So in this case we add. So it's 1 plus 0.23, and then we get 1.23, and t goes on the top. Our general equation, our general equation is just the number, the start value, then 1 plus or 1 minus. Okay, let's do another one. Maybe you'll get the idea after a while. So here, this one here, so we're going to erase all this stuff we drew over here. I'm going to quickly erase all this, okay, and that, and we're just going to do the second part. Okay, we'll just delete all that, and we'll bring the other part up, so we got lots of room so you can see everything. So B, a piece of 100-gram metal is rusting. Each year it decreases, so you look at the word decreases. So when you do this, so if you want, maybe I'll just start off with the general equation. Let's go back up. Okay, the general equation, so y equals a to the c, and c is either plus or minus. So let's write y equals a to the c. This might help some people. Okay, we'll write over here, we're going to write y equals a c to the x. Okay, so y equals, but we're not going to use y. Okay, we're going to say a metal gram rusting, piece of 100-gram metal is rusting each year. Decreases, so mass. We're going to use m. Instead of y, we're going to use m equals, okay, a is the starting value, 100, and then we're going to put a bracket to the x. So it's going to kind of look, the a is going to be the 100, c is going to be either 1 plus or 1 minus. So it decreases, so there's going to be 1 minus. Now you have to take the 5.2 and divide it by 100. So you take the 5.2 divided by 100, and you get 0.052. 0.052. So here you put 0.052, and it decreases, so it's a minus. Let's extend this down. So my mass equals 100. Okay, 1 minus that, so it's 0.948. You can use your calculator. To the x, instead of x, I'm going to put to the t. Okay. Now I'm going to say m is the mass. Okay, and let's see what is it, grams or kilograms? Grams, and t is the time. So here the mass is in grams, and the t is the time in kilogram, in years. Sorry, in years. Okay, let's move on to the next one. Okay, a boat costs $5,600. The value drops by 27%. Create an equation. I think I prefer the first method I did. I'm going to go 27 divided by 100 to find my percent. So I get 0.27. Then I'm going to say a boat, so cost. So I'm going to put C for cost. C equals, you put your initial value, put a bracket, 1. Now it drops or decreases, so it's minus 0.27 each year to the time. Okay, so then our equation is C equals 5600. Now I can't do that one in my head, so I'm going to grab my calculator here and figure out 1 minus 0.27 is. So 1 subtract 0.27. Oh, let's clear all this. 1 minus 0.227. 0.73. So in here you get 0.73 t. That's our equation for this one. Let's lower it down. That's our equation. Now, let's see. C is the cost in dollars. And t is the time again in years. Okay. Okay, let's look at two more and we'll pause the video and we'll do another one. So ball is dropped from 120. On each bounce, the ball rises 80% of the height from which it fell. So this one's a little different. This one you don't add or subtract. It's 80 of the value. You have that word of. So here, let's see height. So the height of the ball, h, equals initial height's 120. Okay. Then you put just 80%. Oh, I should have turned 80% to a decimal. Percent divided by 100 is 0.8. So then you just put 0.8 in here to the power. It always seems to be n here, maybe, or t. This time n. So that's our equation. Okay. H is the height. And that's in meters. Okay, and n is the number of bounces. Okay, n is the number of bounces. Okay, next one. We start with 250 grams of one bacteria. This bacteria doubles each year. So grams. So we need like a mass, m. So m equals 250. And then it doubles, so we put a 2 in here each year to the power of t. So m is the mass in grams. And t is the time in years. Okay, I'm going to stop this video and we'll continue with the next video.